Hello everyone, welcome to our session at Mobile World Congress. We're going to talk about MANO enablement, and we're presenting with Jeff Gowan from WindRiver, and myself, I'm Patrick Root, I'm the CTO at Nikina Systems. So if you look in the world of NFV and where it's going today, what you're seeing is there's going to be a lot of change going through in the network. There's going to be a lot of virtual functions mixed with traditional physical functions. They're going to be used to roll out both commercial services, mobile services, as well as residential services. As you see that there's going to be a lot of complexity added to the networks. Networks aren't really getting simpler, they're actually getting a little more complicated, or maybe some would say a lot more complicated, with a lot of the parameters and the scaling in, scaling out of NFV. You're going to see a lot of increased attack surface for security problems, potentially, as well as a lot of issues with how these things interact with each other. So if you're going to actually move forward with NFV, you really need carrier scale, carrier grade, industrial strength solutions if you're going to work in that carrier market. So, as I was saying before, as you move into that virtualized market, you're going to see actually more changes in the network and more things actually interacting in that network. So a lot of the devices will be contacted from orchestrators. There'll be people still going to log into a lot of those network functions. The functions are going to be connected in different ways to do different service chaining and service definitions. There's more parameters. And there's going to be a lot of a mix between physical and virtual infrastructure. So what we do at Nikina is we bring it all into a common platform. So what we have is what we call the NI framework. And what this does is it provides a virtualized or abstracted view of the network across both physical and virtual elements, providing it in a way that you can basically apply a set of applications at the higher level, be that orchestration, or other OSS types of solutions, and interact seamlessly amongst the different types of environments. What's needed at that lower layer is the ability to bring in the different elements via adapters, be them working on virtual functions or physical functions and how they're interconnected. So at Nikina, where we're playing is the interaction with. Are you guys all familiar with the famous Etsy model? So where we play is in the management layer above the virtualized infrastructure management, and Jeff's going to get into a bit more about that and the infrastructure. So where we play is the ability to define with our NI Creator product the modeling of those virtual functions within the network, as well as the ability to string those together to form a service chain or a service model made up of pieces that are implemented within the virtual network. We also provide interfaces to talk to the virtual infrastructure manager, the VNF managers, and the virtual functions themselves to make sure they're configured properly, end to end, as well as to do inventory and reconciliation of the data. As the data is moving around and virtual functions are appearing and disappearing, orchestrators need correct information if they're actually going to make the decisions and actually work. And what we do is provide integrity of that overall system all the way from the virtual infrastructure, through the VNFs, through the physical network, up to the top, so that the orchestrators can actually make good decisions. And now I'm going to turn it over to Jeff. Touch the bottom, don't be like me.
Thank you, Patrick. Again, my name is Jeff Gowan. I'm with WindRiver. And so what you're seeing here, I kind of think of as a simplified version of the previous slide, and it really represents our Titanium cloud ecosystem. So what that is carriers need to have the ability to make choices in terms of what solutions that they need. So we start with our WindRiver Titanium server software, which I'm going to get to in the details in just a moment, and we've partnered with folks like Nikina for the various pieces of the NFV infrastructure. So as you can see, we have standard relationship with standard server platform providers, VNF providers, OSS, BSS, and then of course management operators like Nikina. So Titanium Server is our sort of NFV infrastructure. We started with open source, and so for example Linux, open source Linux, and we've hardened them and sort of made them battle ready for carrier grade. So it's one thing to be able to achieve 99.9% reliability like in a standard IT implementation, but the carriers need something closer to 5 nines. And so with our solution, we actually guarantee 6 nines reliability. So again, starting with Linux, we add our carrier grade to it. We've got our own KVM, and then we layer on top of that our accelerated vSwitch, which actually offers 20 times the performance of Open vSwitch. And then we layer in some management and middleware. And so within the Titanium Cloud infrastructure, again, we have our piece, and then we pre-validate the pieces like Nikina, so a telco provider will be able to know that our pieces are going to work well together, they're going to play well together and with others. Oh, and one thing I forgot to mention, so with our infrastructure, you're not locked into a particular OS, so it runs with any guest OS, so again, enabling that choice for the provider. If they choose to use Red Hat, that's fine, we operate that way. So just to recap, again, Titanium Server offers 6 nines reliability guaranteed, virtual switching 20 times greater than Open vSwitch, fully integrated platform, that's really the Titanium Cloud infrastructure, and then it's an open software solution. We start with open, we harden it, and we make it carrier grade. So I think at this point you guys have a demonstration?
Yep.
So hand it back over to you.
Sure. Sorry, what? What's that? So what we're showing here is a summary of our configuration auditing product. And what it's showing here is a cross hybrid network that consists of both NFV and SDN elements, overall compliance for configuration. And so what we're showing here is across different types of elements and different regions. So within this particular network, you can see it broken down by element type. So in this network, we have a number of Cisco HRAN elements. There's Ericsson devices, and in this case, a Viata virtual router running in the WindRiver platform, as well as the NFVI infrastructure itself. And we actually had downloaded some things from an SDN company called Corsa. So we had some SDN elements in here as well. So what it shows is basically that mix that we showed on the first part. You're going to have all of these different types of elements. So what the Nikina system on the framework does, it pulls in all the different elements into it that it's discovered in the network and downloads the configuration. So what we're showing here is we have some Cisco, some ALU, and in this case the SGSN, which is the actual Titanium server. So there's a couple instances of these different elements. Now we can go and look at what do we actually pull from one of those elements when we're actually talking to it. So in this case, it's the WindRiver. We're going to have a look at what we have inside it. And from there we can see the things running in it. In this case, we only have one Viata router running in there right now, and you can select it and see how it's configured, the various attributes that are associated with that router. This shows how it's configured and what it's set up for, how much memory it's got, how many CPUs, disk space, and all that kind of stuff when it gets turned up, as well as the infrastructure that the actual Titanium server is running on. So what we can now what we're showing now is the ability to run a configuration audit of this infrastructure against the gold standard that's been defined by the service provider. Normally these get run in batch mode, but this is a one-off running it directly. So what it's doing is now comparing the configuration that it's gotten from the network with the gold standard configuration. In this case, it's found one particular highlight. In this case, the Viata router was spun up with 2 gig of RAM. It was supposed to have 4. That's what the template was supposed to be. So what it'll do is it'll highlight these different kinds of discrepancies in the network. Here what we're showing is a version of the gold standard with the actual planned and values that would go into that device. So at this point, you can use that to detect changes in the network in the virtual routers, as well as in the infrastructure to make sure they're configured properly. And that's, in a nutshell, where we were going to leave off. Any questions? Okay, thank you very much.